Well, thank you very much for having me. My pleasure and privilege to be here. How close do I need to hold this thing to my mouth? Okay. So, I believe if I press this button, you all see what should be there. So I have the privilege of speaking to you tonight on distant starlight and biblical creation. And does distant starlight disprove the idea of biblical creation? This proves the spirit world is real. See? Empirical evidence right here in front of us. So this is a fun topic because it's unusual among creation presentations. Typically in a presentation like this, we would talk about whether or not neo-Darwinian evolution is a scientific supportable model or not. I would argue it's not. We would talk about evidence for long ages or short ages in fossils and rocks and so on. Tonight's presentation, though, is unusual in that it is answering a common objection to the biblical worldview. Rather than presenting positive evidence for our side or negative evidence against the other side, this is an attempt to answer a challenge that people give to us. How is it that if creation happened not all that long ago, how is it then possible that we see light from these objects that are so far away? How could starlight have left these distant objects, traveled through space, vast distances, and still arriving here on Earth in time for us to see them if creation happened recently?
Yeah. And this esteem that there's no sound coming through.
So how would we answer such a question? Well, this is a kind of calculation that we actually do every day in our lives, maybe not every day, but commonly in our lives. So if I need to drive 120 miles, and I'm going to drive 60 miles an hour, how much time will it take me to do so? 2 hours, right? That's a simple calculation. What are we actually doing to perform that calculation? We're evaluating the time as a result of the distance divided by the speed. So this is how you calculate a travel time, this simple equation. So yes, there is going to be math in this presentation, but as you can see, it's a simple thing to talk about, hopefully. So time equals distance divided by speed. Now when we apply this to the cosmos, we're dealing with vast distances, of course, and we use a unit called a light year. And despite the name, a light year is not a unit of time, it's a unit of distance. It is the distance that light can travel in 1 year. So looking out on the cosmos, we see a variety of wonderful things, in some familiar parts of the sky even. To the eye, we can only see some stars, but of course with telescopes and other equipment, we can see much farther. What I'm showing you here is the Bubble Nebula, which is within our own Milky Way galaxy, and is about 7,000 to 11,000 light years away. So let's call it 10,000 light years to make the math easy. So if we can see something that's 10,000 light years away, how long did the light need to get here? Well, back to our equation, if time equals distance over speed, and the distance is 10,000 light years, and if light travels 1 light year per year, then the answer is 10,000 years. So this is a straightforward conversion, really, because when you see the distance to something in light years, that tells you how many years it apparently would have needed for that light to travel here. And even within the Milky Way galaxy, as you can see, this particular object, 10,000 years for the light to get here, that would exceed a 6,000 year age since creation, wouldn't it? Looking even to local objects, relatively speaking, we see the Andromeda galaxy, one of the closest galaxies to us. It's 2.5 million light years away. Therefore, presumably, the light would need 2.5 million years to get here. And of course, with modern technology, laser-guided observatories, for example, to compensate for atmospheric turbulence, and even space telescopes, we can look much, much farther out into the cosmos than was previously possible in human history. Space telescopes regularly look out to distances of billions of light years, like this Hubble Ultra Deep Field photo. And the farthest object seen so far is this one at 13.5 billion light years away, which would imply it took 13.5 billion years for the light to get here. So what do we do with that? Well, according to the atheists, we can't do anything with it. They think this is a slam dunk argument against creation, and they even dedicate this fairly lengthy page on this atheist wiki to the subject. I mean, it seems like a straightforward challenge, right? You can summarize it in just a few words. We see distant stars, 4 words. Knockout punch? No. We'll see that in just a moment. First, we should discuss why this matters anyway. Why should long time scales seem to pose a challenge for us? Well, the Bible says that Adam was created roughly 6,000 years ago. And we can calculate that from adding up the genealogies and so on. And the Bible says that in the beginning God created the heavens and the earth, that God created man in his own image. And behold, God saw everything that he had made. Behold, it was very good. Evening and morning were the sixth day. So Adam was created on the sixth day after everything else was. So if Adam was created 6,000 years ago, then the rest of the creation is only 6 days older. And of course, there are some Christians who think that somehow we should interpret the Bible to allow for long ages. There's lots of reasons against that. I'm just going to quote Mark 10 here. When Jesus was being challenged on a particular issue, his opponent said, Moses permitted a man to write a certificate of dismissal and to divorce her. They were arguing about divorce. But Jesus said to them, he wrote this commandment for you because of your hard hearts, but at the beginning of creation, God made them male and female, confirming that Adam was indeed created right after everything else was. And I've actually heard people say, well, maybe Jesus didn't know when creation happened. Well, we know that raises even bigger theological problems because John chapter 1 tells us he was the creator. All things were made by him, and without him was not anything made that was made. So he would know when he did it, which was 6,000 years ago. So is this actually a fatal challenge, then, to the biblical creation worldview? Well, not so fast. This challenge actually applies to everybody, not just us. If you're coming at this from a Big Bang perspective and you want to believe in the Big Bang and the billions of years and all the rest of it, then you would also accept that the cosmic microwave background, the CMB, which is this radiation coming to Earth from all directions in space, you would also accept that this is the afterglow of the Big Bang, because this is now part of the model. However, this is interesting because this supposedly was formed just a few 100,000 years after the Big Bang happened. The Big Bang model says there wasn't enough time back then for light to have traveled across the entire universe. Therefore, heat energy could not have traveled across the entire universe. Therefore, the Big Bang model predicts temperature variations throughout the CMB. Different parts of the universe should be at different temperatures, according to the Big Bang, because there hasn't been enough time for the temperatures to equalize. Despite that prediction, the entire universe is at essentially the same temperature, to within a thousandth of a degree. This is called the horizon problem. Light has apparently traveled across the entire universe, even under a Big Bang interpretation, but the Big Bang interpretation says there's not been enough time since the Big Bang for it to have done so. So in other words, the Big Bang model has a light travel time problem of its own. Now, if you talk to someone about this who's knowledgeable about the model, they'll say, well, yes, but this period of inflation happened right after the Big Bang, which actually explains away this issue. It does explain the issue, but only at the cost of introducing something into a cosmological model that's completely outside of known physics. Inflation is a hypothetical process where the universe blew up by 10 to the 30th power in a billionth of a billionth of a billionth of a second. And I know those are big numbers, so imagine something the size of a dime blowing up to the size of 10 million galaxies side by side in less than an eye blink, in far less than an eye blink. That's an expansion rate much faster than the speed of light. That's what has been added to the Big Bang model to explain away this time travel problem. My overall, and I don't want to get too much into the weeds about inflation and the other problems with the Big Bang here tonight. My point right now is that the Big Bang model has a light travel time issue of its own. So LTT, light travel time, is an issue for everyone. We're on an even playing field here. Having said that, we aren't on the defensive as Christians. There are actually multiple possible solutions, which is my purpose here this evening. Now, I'm not here to present the solution to this problem. Most people who speak on this are advocating a specific solution. I'm actually here to present the spectrum of solutions that are being discussed within the creation movement today, because I think that's more useful and more interesting. And to do that, I'm going to do my best to present each of these positions independently and with their best arguments. Each of the ones I'm presenting as a possible solution has been endorsed by at least one credentialed scientist within the creation community. And by credentialed scientist, I mean PhD in physics, astrophysics, or astronomy. So these are all credible ideas. I'm going to do my best to hide my own personal views to present all of them fairly. Which means during Q&A, someone's going to ask me what my personal view is, but we'll deal with that when we get there. So there are actually 7 assumptions built into the LTT challenge. It seems like a straightforward problem, right? We see distant stars. How could light get here? Well, that simple statement holds multiple assumptions within it. And if any of these 7 assumptions are wrong, then the challenge is not a valid challenge. It falls apart. Because all 7 of these assumptions have to be true for the challenge to be substantial. And as we'll see, at least one of them is certainly false, while all the rest of them can be questioned. So what do we mean by assumptions? Well, back to our equation. If time equals distance over speed, well, that calculation assumes that the speed hasn't changed over time. A while back, it was suggested that perhaps the speed of light has actually decreased over time, so it used to be much higher in the past. And you can imagine if light used to travel here much more quickly in the past, then obviously that would decrease the time required for it to have arrived here. This idea got a lot of interest within the creation community, and a lot of people looked into it. Subsequently, some problems with it were found. My point right now is that this is a crucial assumption within that calculation, right? If the speed of light had changed, then we see the calculation wouldn't be producing a trustworthy result, because it would be based on today's value and not the applicable value in the past. However, as I mentioned, the creation community has mostly moved on past this idea. This assumption appears to be true. At least the consensus opinion among most scientists in the movement would say that the evidence that was presented for this didn't really withstand further scrutiny. So of the 7 assumptions, this one appears to be valid. All the rest of them, though, we will talk about, can be questioned. So, back to our equation, we see that speed is a factor, as we just said, but this not only assumes that the speed of light hasn't changed, it assumes that we know what the speed of light is. And you might say, well, of course we know what it is. You can look it up in a textbook or on Wikipedia or whatever. Well, you can look up the round trip, the two-way speed of light on all these various sources. What you can't find out is what the speed of light is when light only travels in one direction. This is called the one-way speed of light issue, and it too has its own Wikipedia page. It is actually impossible to measure what the speed of light is when it travels in only one direction. For various reasons, we can get into details later if you're curious, but all the ways of calculating it, only making a one-way trip, you have to first assume that you know what the value is before you can measure it, which obviously is not valid. The only way we can measure it is when it makes a round trip, but that's not what's relevant to this equation, right? The equation is how fast, or the equation includes the speed for when light travels to here from there, and not when it goes in both directions. So I know this is kind of a strange concept. Why would it be different in only one way? Well, again, we can talk more about details later if you want. My point right now is, even among secular scientists, it is admitted that it is impossible to know this. And it's not merely a question of our technology isn't good enough yet. It's theoretically impossible to ever measure this value without first assuming that you know what it is. But you have to know what it is in order to make this calculation. And since we don't know what it is, that means that we can't do the calculation. Therefore, of the 7 assumptions, we see that number 2 is wrong. The one-way speed of light is not absolute, and we don't know what it is, so we can't make that calculation. So the whole question is moot. It's invalidated. I always wanted to say the word moot. It has a nice ring to it, doesn't it? Especially when you lift up your voice at the end of it. What else can we glean? I mean, in theory, we could actually stop this discussion right here because we've already shown that this challenge falls apart. It requires that we know a value that not only do we not know, it's impossible to ever know it. So this calculation can't be done. But it's too early, I'm told, to stop the presentation here, so let's continue. Because there's more assumptions we can talk about yet. We've talked about speed. What about distance? This calculation assumes that the light beams traveled the whole way to get here. What if that's not the case? What if God created the light beams as complete light beams? Fully functional beams created in place in between the stars and the Earth. And people who hold this view point out, correctly I believe, that if the heavens are to declare the glory of God, shouldn't they do so right away? When Adam woke up on day 6, shouldn't he be able to see all the stars immediately, with the light beams already connecting him to them? This used to be called the appearance of age, but a better description is mature creation. That God created the creation in a mature, functional state so that it could operate correctly from day 1. That includes the heavens declaring his glory. So all the beams of light were created in place so that people could see all of these objects and glorify God through them. In fact, the advocates of this view point out that it's certainly necessary in some of what we see for creation. For example, Adam woke up next to fruit trees and other plants that he could eat. Now, a fruit tree takes several years to grow and start bearing fruit, right? Did Adam have to wait several years before he could eat anything in the garden? I mean, obviously not. So we know at least a good part of the earth had to be created functional and mature. So why not the cosmos too? Now, I mentioned that I'd be presenting the arguments for each of these views. I will also describe some of the reasons that the people who don't hold to these views, why they don't. And a common objection against this idea is that this would make God deceptive, because it means we would see things that didn't actually exist. For example, in the year 1987, we observed a supernova where a star exploded. That's now called supernova 1987A. And this star was 168,000 light years from us. And we saw the star before it blew up. So we saw the star, then we saw it blow up, and subsequent to that, we've seen the supernova develop over time. There's these rings of expanding gas, and there's actually some interesting physics going on here with how supernovas develop over time. Now, if God created the light beam in place between us and that faraway thing, well, that light beam was 168,000 light years long. And the Earth has only consumed the first 6,000 light years of that beam. So that means, according to the mature creation view, that the Lord created this beam of light in place. Is my clicker working? Yeah. Here. And then over time, that beam of light has been moving toward us. Now, at first, the closest part of this light beam contained images of this star, which again we observed. And then we saw the star for the first 3,000 years or so, and then kept consuming the light beam until 1987 happened, and we saw an image of a supernova. And no extra charge, by the way, for the Hollywood quality of graphics that we're using here. But did this star shown here ever actually exist? No, because it was just images in this light beam followed by images of a supernova that didn't happen either. And now we're watching different images of a supernova develop over time. What's on the far end of the light beam? We don't know. We haven't seen it yet. And we're not going to see it for another 162,000 years. So people who don't like this view say this makes God a deceiver because he's showing us things in the sky that never actually existed. The advocates of the view answer, well, wait a minute, is it deceptive if God told us what he did? Was Adam deceived by the fruit trees? It's like, wait a minute, God, you couldn't have created these on day 3. These are at least 4 or 5 years old. Well, no, because God told him what he did. Similarly, if God tells us that he created the cosmos recently, he's not deceiving us by these things that we see. One last thing that they say is, even if you don't like this idea, you still have to admit that it applies to at least part of the cosmos. Yes, clearly the Earth had to be created mature. It's inconsistent, though, to say that all stars could not have been created mature, because at least one has to have some elements of mature creation within it. What do I mean by that? Well, our current understanding of solar physics tells us that light is generated deep inside the sun by nuclear processes, and the photons get absorbed by material inside the sun, absorbed, re-emitted, absorbed, re-emitted, absorbed, re-emitted. They take a while to work their way out to the surface. Now, once the light reaches the surface, it shoots to us through space at the speed of light and gets here in 8 minutes and 20 seconds. But it takes thousands of years, potentially millions of years, depending on which model you look at, for the light to get there. So if we can see sunlight today, and of course we can, we are seeing sunlight that was not generated by the sun. Instead, we are seeing light that was created somewhere in between the sun's innermost and outermost parts that was on its way out to us. Does that make sense? So it will take us a while yet to ever perceive sunlight that the sun is actually generating. So the point here is that the sun had to be created mature in this sense, in that its light had to be created on the way to us in order for us to see it today. So why not the rest of the stars too? And again, I'm not arguing for or against this position. I'm just showing you the different things being discussed by the advocates and the non-advocates of this position. So that was the third assumption built into the LTT challenge, that the universe was created mature. That it was not created mature. But if it were, then this challenge would not be valid. What other assumptions are there? Well, back to our equation. Perhaps we can question distance a different way. This calculation assumes that light traveled to us over the entire distance through naturalistic processes. What if that weren't true? Genesis 1 says, "And God said, let the earth bring forth grass, the herb yielding seed, and the fruit tree. And indeed, the earth did bring forth the grass and seed and the tree," etc. Now, a number of years ago, an astronomer was reading this and said, there's something interesting here that I hadn't expected. A lot of us read a passage like this and we just kind of assume that the Lord said, let there be plants, and boom, there was plants. That's not actually what this verse says, right? God didn't say, let there be plants. God said, let the earth bring forth plants. The Hebrew word here is called dasha, bring forth. And so this astronomer said, well, if plants were commanded to come forth from the earth, and they did that all in one day, it sounds like they grew in a normal way, but just a very accelerated process. What if that same logic applied on day 4, when the Lord created the contents of the heavens? Is it possible that starlight traveled here also through an accelerated process all on day 4? That it traveled here in I want to use the word normal, but it did travel here from these objects, so we're not being deceived by seeing objects that never existed, but nevertheless the light was brought here very quickly through a supernatural process. And that last word, supernatural, is a hint to why some people don't like this idea. It's explicitly miraculous. It says, yes, this whole process was a miracle. And the answer is, well, yes, it is miraculous, but so is the universe itself. If you consider the creation of the universe, you look back into history far enough. That must be my other personality. You look back in history far enough, you're going to run out of the laws of physics eventually, right? There are miracles in Creation Week, and we shouldn't be embarrassed about that. Still, this makes some Christians uncomfortable, and they say, well, that's not very useful when talking to a non-believer. Well, I would take a different tack with a non-believer. I would point out that their worldview includes miracles too, inasmuch as any secular cosmology has to violate the laws of physics, one way or the other. And if you're curious about that, ask me during Q&A. There's more I can say about that. I think it's kind of a fun topic. You can show that without a creator, every model for the universe's existence that you can possibly come up with has to violate a law of physics in one way or another. So a non-believer, therefore, has to believe in a model that violates physics, which means he believes in miracles, while denying that miracles are possible. We affirm miracles while knowing who the miracle maker is. So we're consistent, and the atheist is not. Moving on, though, one other objection to this dasha cosmology, as it's sometimes called, that the Lord supernaturally accelerated starlight to us, is that it's difficult to figure out how we can make a prediction based on this idea. In order for it to be a good scientific model, we have to be able to confirm it or falsify it using observations and data. And as of yet, there hasn't really been any firm prediction suggested by this proposal. But at least it shows us that there's another assumption built into the LTT challenge that isn't necessarily true. What else can we glean from this equation? How else can we look at assumptions within it? Well, let's go back to speed and revisit that for a moment. What if the speed of light has changed? Well, you say, wait a minute, you said earlier that it didn't change. It didn't change through time, apparently, but what if it changed according to location? What if it changes through space? Because think about this, where have we ever measured the speed of light? All of our measurements have been done within our solar system. within the gravitational field of our sun. And maybe that matters. For that matter, our sun is located within the Milky Way galaxy, so we have never measured the speed of light outside of the gravitational influence of a star, or for that matter, an entire galaxy. What about elsewhere? We've never measured it outside of those boundaries because we have no ability to do so and won't for any conceivable future. But we do know that mass affects space-time and it can affect the path of the speed of light. You may have heard that relativity portrays space-time as a fabric. Stuff distorts the fabric, if you will, of space-time, and it'll actually bend light, the path of a light beam. And we know this. This has been observed many times. Well, if it can affect light's speed, can gravity also affect light's path? Excuse me, I said that backwards. If it affects light's path, which we know that it does, can it also affect light's speed? Perhaps in deep space, when you're far away from any star, light would travel more quickly. You could see how that would decrease the amount of time necessary for the light to get here from there, right? Especially from faraway galaxies, the light would spend almost all of its time traveling in between galaxies in intergalactic space. So if the speed of light was higher out there, that would greatly decrease the amount of time required for the light to get here. This idea is gaining interest within the creation community. We're actually kind of late to the party on this one because the secular community has been talking about this idea for years. They're called VSOL models, variable speed of light. Now their motive, the people who are talking about this on the secular side, their motive is not, of course, to affirm that God created the universe. They're trying to solve problems within their own models with this idea. I'm just pointing out this isn't some idea that only the creation community came up with. Even among secular scientists, there are people looking at this idea. So back to our assumptions. Assumption number 5 is that light speed is constant throughout space. That's not necessarily true. And if it's not true, you can see how the LTT challenge falls apart. Well, I promised 7 assumptions, and that's only 5. So what else can we get out of this equation? Have we beaten it to death yet? No is the answer, because now we can talk about time. What do I mean by that? Well, when we think about creation, we tend to think of an inner to outer order or sequence for creation. So in the beginning there was nothing, and then the Lord created the earth, and then he created the cosmos around the earth. That's how we usually think of it. What if, though, that could be true from one perspective, but somebody in a different location would perceive a different order of events? What if, in the beginning, when the Lord began to create, he first, and I'm kind of abusing the word first here, but first created the outermost galaxies from our perspective, and then the ones farther in, and then the ones farther in, and he did so at the same speed as light travels, so that as this happened, the light from these newly created galaxies begin to be emitted, and then traveled inward at the same speed as these were created, which means this light is now accompanied by light from here, which means as the next ones were created, all this gathered light is accompanied by the ones, by the galaxies emitting light there. And so the Earth receives all of this incoming starlight all at the same time from all directions. So in a sense, from the Earth's perspective, everything appeared on the 4th day, because if you were on Earth, you'd at first perceive an empty sky, and then on the 4th day, or the 4th night, I suppose, all of that light would arrive here at the same time in all directions, from all directions. So you would perceive an empty sky, and then on the 4th night, a full sky. So from an earthbound perspective, that's when creation happened. That's when all of those other things were created. Now, people have an immediate objection to this idea. It's like, wait a minute, that means that all those other things were created before the Earth, because they were created first. And I've already highlighted the word first there. That objection makes a subtle assumption. You're assuming that there's an absolute time scale, an absolute sequence of time throughout the cosmos. And that's actually not true. On large enough scales, or for that matter, when things are moving quickly relative to another, you can no longer say that there's an absolute sequence of when everything happened. You instead have to pick a perspective from which you determine the sequence. And you do that by assuming that things are happening as you perceive them. And this is going to get a little strange here, so bear with me. But if you were on Earth, during this time. Like I said, you'd see an empty sky and then suddenly it would be full. Even though from the perspective of someone in a faraway galaxy, they were created first, and then the Earth happened later. But from the Earth's perspective, you're treating everything as happening when you observed it, and therefore everything appeared on the fourth day, and the Earth was created initially before everything else was. Those of you within the creation movement will recognize that this is the Anisotropic synchrony convention, the ASC cosmology. And if it still seems strange to you, let me ask you this. Are you experiencing this presentation tonight as it happens? You thought so, right? Have you thought about the fact that you're not actually experiencing this live? Light doesn't travel infinitely quickly, or neither does sound. You are receiving the light, the image of me speaking, and the sound of my voice with a slight delay after the time I'm emitting these things. So you're watching this whole thing on time delay. And that's going to bother some people now. But you don't think about that, right? You treat it as if you're experiencing it as it happens. And we do this all the time. When we see Venus transiting the sun, which is a very rare event, by the way, do you say, wow, I get to see this rare event that'll never happen again in my lifetime, this is amazing? Or do you kind of grumble and say, well, it takes the light over a minute to get here, so I'm just watching a time delay movie, it would have been nice. Well, no, of course not. Commonly, even in astronomy, we timestamp events by when we perceive them, not according to some absolute measure of when they happened. And we've seen an example of this already tonight. We don't call this supernova 166,000 BC. We call it supernova 1987A because that's when the light got here. So similarly, if the light got here on day 4, and that's when all the stars were first visible, then that's when they were all created from an Earth observer's perspective, and Genesis is most certainly written from the perspective of an observer, if not on Earth, at least from that with that focus. And indeed, you can take this idea out farther. There's no actual absolute sequence of time that can be applied on cosmic scales. And if anyone wants a little mind bender on that, ask me during Q&A. There's a fun demonstration we can do to get you really scratching your head. For now, I'm going to move on, though, and point out that light speed is not necessarily, excuse me, that's the previous assumption. The assumption is that we must use an absolute sequence for ordering events in the cosmos, and that's actually not true. We know that not only from the examples I gave, but relativity itself says that it doesn't apply on a cosmic scale. So back to our equation. Is there anything more we can extract from this simple equation? Yes, and we are going to visit time once more. We assume, or we tend to assume, that time is this absolute thing, that a second takes 1 second to tick on the clock, and that it'll do that the same everywhere. That's actually not true. There's a phenomenon called time dilation. This arises from Einstein's relativity. It was understood to be a consequence of his equations fairly early on, but for a while we didn't have the ability to test it. Now it's been tested multiple times, and this is that gravity affects time. The deeper you are in a gravitational field, the more gravity you experience, the slower time flows for you. What do I mean by that? If that seems like a weird concept, here's a different way to put it. Every possible clock you could build, whether it's based on mechanical processes or chemical processes or atomic processes or whatever, every possible clock measures time more slowly in stronger gravity as compared to weaker gravity. And as I said, this has been confirmed experimentally many, many times. In fact, we actually have to compensate for it in some of our technology. I'm showing you here a GPS satellite. GPS satellites are farther out of the Earth's gravitational well than we are down here on the surface. The device in your pocket actually has to compensate for this because clocks up there tick. They use clocks that don't actually tick, but their clocks tick a little bit more quickly than ones down here on Earth. And GPS actually works on calculating times across us and the satellites and relies on having an absolute accurate notion of how time is flowing. GPS actually experiences a time speed up, if you will, relative to, well, let me put it the other way. Time for us flows more slowly than GPS satellites by 45 microseconds per day. Now that's not a whole lot, but it is enough to make GPS inoperable pretty quickly because the clocks go out of sync. There's actually a second effect in this that I won't take the time to talk about. On a net basis, GPS has to calculate 38 microseconds per day difference between the satellites and us in order for the system to work. So if you got a little device in your pocket that has maps and such, realize this time dilation effect is very real. Not only was it predicted by theory and then confirmed by experiment, some of our technology has to compensate for it in order to work. Okay, so how do we apply that to our question? Well, the Bible says in multiple places, thus says God the Lord, he that created the heavens and stretched them out. Need to apply more time to the amount of words per second here. So, a physicist a while back was reading one of these verses and said, is that poetry? Or did the Lord physically stretch out the heavens in the very beginning? And if he did, what would that look like? Well, if he stretched it out, that means it all started out in a smaller volume than it is today. What if the volume was really small? What if all the stuff in the universe was initially in a small enough volume that it would be inside of a black hole? Now, black holes are pretty strange things. This diagram here, I'm representing this concept. This is all the stuff in the early universe, and this dotted line is the event horizon surrounding it. This is the boundary of a black hole. It's not a physical thing. It's not a shell or something. It's just a distance. So if you have enough stuff, then you have this distance from the stuff, or from the mass, within which all the black hole weirdness happens. Now, black holes were theoretical things for quite some time. It was understood that relativity predicted them. But he said, well, how do you verify that they exist if by definition you can't see it? If there's so much gravity there that even light can't escape, then it's just going to be black. That's why it's called a black hole. Well, you can see the effects of a black hole, like matter being ripped apart as it gets pulled in. This is called an accretion disk. And we are finding examples of this now that we have good enough technology to find them. And indeed, black holes do appear to be real things. Not that this is surprising because they're predicted by good physics. But back to our biblical idea here. If the Lord created everything in such a small volume that it was inside of a black hole and then started stretching it out, well, as it stretched, the black hole would begin to shrink. The event horizon would move inwards. Now, at this point, everything is still inside the black hole, and perhaps the Lord started creating things at this point in the process. But if he continued stretching, more stuff moved outwards while the boundary of the black hole would move inwards. And now, some stuff is outside of the hole while the rest of it is still inside, and the Earth is still inside under this proposal. And here's where it gets interesting, because one of the weird things about black holes is that as you approach them, due to this gravity and time effect that we talked about, time slows down and stops once you reach the event horizon. So if time is stopped inside the black hole, well, then time isn't flowing here, but out here, time is flowing. So now you have no time passing inside, whereas time is passing outside. This continues. The Lord keeps stretching. The universe gets bigger. The black hole gets smaller. Again, more time is passing outside than inside, and more stuff is experiencing time passing outside, whereas the Earth is still inside. Eventually, when the universe was stretched large enough, the black hole would essentially collapse and vanish. Collapse, I don't like to use the word collapse there. Nothing physically collapsed, but the black hole would go away. So from this point, all clocks in the universe are proceeding at the same rate, except for local variations, like if you're next to a planet or a star like we talked about. But what happened before this point? Remember, the Earth stayed in the middle of the hole until the very end of this process. Lots of time passed out here, while in here passed 24 hours. So you could have millions or even billions of years passing out here, giving time for light to travel here from there, also giving time for galaxy collisions and other things we see happening out in the distant cosmos that would appear to need a long time to happen. While nevertheless, a clock here would measure 1 day. And if you ask this physicist, how old is the universe, he'll say, according to which clock? Because that matters. The clocks out here measure millions or billions of years. The one here measured 1 day. Which of them are correct? They all are, because time can flow differently in different locations if matter is distributed in a certain way. So this is called a time dilation cosmology. The version I just presented to you is the first of several proposed by this physicist. That is, newer ideas are more complicated, and I like using the first one because I think it illustrates the concept a lot more clearly. That depending on how mass is distributed, time can flow differently in different locations. And if we build a cosmology out of that, we can see then how light could travel here, even though the Earth itself is young. So that was assumption 7, that time has always flowed uniformly throughout the cosmos. That's not necessarily true. Physics shows us how maybe it didn't. Let me reword that. Physics shows us that time doesn't need to flow uniformly depending on the circumstances. And depending on how the Lord did it, it's possible that different clocks measured time differently in the early universe. So those are our 7 assumptions. Stepping back for a minute and asking the question, does distant starlight disprove biblical creation? No. You see, we have lots of options here, right? There's lots of tools in the model building toolbox. Which one of them is correct? Well, maybe it's a combination of some of those elements, or maybe it's yet another idea that hasn't been proposed yet. My point is, this is not a showstopper for us, right? There's multiple different possible solutions that we're exploring. And as a friend of mine points out, this is actually a great time to be a biblical creationist. If anything, we have an overwhelming variety of options to explore. We're not limited. Because, as I said, many possible solutions, or maybe even a combination thereof. And this is just one way in which the heavens declare the glory of God. We are afforded the privilege of being able to glimpse His glory. We can't understand it fully, of course. But even the glimpses that we can glean from the cosmos are wonderful. And I'm thankful that we live in an era where this type of exploration was possible. I mean, even a couple generations ago, space telescopes weren't available. Ground-based observatories were much less advanced than they are now. We're seeing things that no one in history has ever seen before, and able to glorify the Lord in new ways through those observations. So I have a website talking about astronomy from this perspective. You might have gathered this is a rather unusual way to look at things. You won't get this in the mainstream media for sure. Creationastronomy.com is my site. If you like this kind of perspective on things, there's a free email newsletter available to you there. At the bottom of every page in that site, there's a sign-up form. You won't get spammed. It only comes out a couple times a year at this point. But as different things are discovered, different announcements are made, and there's elements to that story that are interesting or not being discussed in the mainstream media, that's what that newsletter is for. I also have a series of 3 videos on astronomy from a creation perspective. They are over here on the table. If you're not familiar with them, I'll talk about that briefly. Volume 1 talks about the solar system. It goes planet by planet through the solar system, showing how each one uniquely discredits secular ideas for where they came from. Some of you might have an older version of this, by the way. It was updated last year in the 3rd edition. It now includes Pluto. In fact, there's so much stuff in this particular video, it's now a 2-disc set. So lots of fun stuff there. Very visual presentation, hundreds and hundreds of pictures and images, graphics from NASA and other sources. As you might be able to tell, I like pretty pictures, so that's how the videos are too. Volume 2 in that series talks about stars and galaxies. Where do galaxies come from? Can they form on their own? What about stars? Is there evidence for intelligent design in our sun? The answer is yes. That's what Volume 2 is about. Volume 3 is where did the universe itself come from? Is the Big Bang a viable model for cosmic origins? Or does it actually have anti-scientific and absurd consequences if taken to its logical conclusion? That is the purpose of that video. So what do the heavens declare anyway? Not the Big Bang model. They declare the glory of God. And it has been my privilege to discuss that with you here this evening. I believe now we have time for questions. Now, I put multiple teasers in my presentation for stuff we could talk about. I don't know what you want to hear, though. So we talked about secular cosmologies almost violate the laws of physics. That's one option. We talked about how our notions of absolute time don't apply on large scales. That we look in the cosmos and see things happening. We can't say this happened before that happened. Absolutely. Another option. Or are there specific questions? And just holler it out and I'll repeat it for the recording.
How do they measure, like the oldest light universe, 13.5 billion years, how do they measure that it's coming from that far away?
How do they measure the distances when these things are said to be so far away?
And it just appeared, so it just appeared. I know they spotted it several years ago. It's the first time they saw that red light coming from there. What makes them think that it's that far away?
Depending on the distance of the object we're talking about, different ways of measuring distance are available. So if something is close to us, a few hundred, maybe a few thousand light years away, we can use triangulation, basically the same technique a surveyor uses, where we look at it at one day and we wait 6 months and we look at it again, and in 6 months the Earth is now on the other side of the sun, so we're this distance, the width of the Earth's orbit, from the first observation, and by seeing that same object from those two perspectives and seeing how much it's moved or not relative to the background, we can calculate a distance. Now, most objects are too far away for that to work. So there's other distance methods depending on what we're talking about. So if some galaxies may have a particular kind of star within them that pulsates, and we can check, the pulsing tells us how inherently bright that star is, and then we can look at how apparently bright it appears to be from our perspective, calculate how much the light has dropped off over that distance, and that tells us the distance. The farthest things away, which is what you're asking about, are done by redshift. There's a correspondence between the redshift of the light that arrives to us with the distance. And the redshift means the light has been stretched out on its path to us. So you may have heard that the universe is expanding, or at least that it did expand in the past. We conclude that because light in all directions from distant objects is stretched out. Now, normally you would think of something, if I throw a baseball toward you, but I was moving away from you at the time, you would expect my motion away from you to be subtracted from the speed of the baseball. But light doesn't work that way because light always has to travel at a constant speed. So if I was emitting light toward you, or a better example, light is reflecting off of my shiny head onto you. If I were moving away from you at 100 miles an hour, that 100 miles an hour doesn't get subtracted from the speed of the light, because light always travels through you at the same speed. This is a strange concept, I know. So it has to lose energy a different way. It does that by essentially being stretched. The wavelength goes toward the red end of the spectrum. So because there's a correspondence between that stretching, which is measurable to us, and the distance, we see these things that are so far away. The light is so far stretched out they're not even visible to the naked eye necessarily. We couldn't use the naked eye anyway, but even if we could, that light would be so far toward the red end. I'm getting too deep in the weeds here. Correspondence between redshift of the light and distance. We can measure the redshift and therefore calculate the distance. That's the short answer. Sorry for going down a rabbit trail there. I hope it answers your question. Yes, sir, way in the back.
Would it be the same with shrinking of it if you were moving forward instead of the reverse?
Yes, that's a blue shift. And there are some objects from which the light is blue shifted. The Andromeda galaxy, by the way, that I showed you, is blue shifted because it's moving toward us. So in X billions of years, that galaxy is going to collide with ours, unless something changes. Yes?
Years ago, I heard an explanation that light is a frequency, certain frequency, and it travels from electron atom to atom. Each atom picks up the frequency, keeps passing it on in space. And the theory was that when God first created the heavens, it wasn't as cluttered as it is today with atoms all over the mixed in space. So the fact that light travels from one atom to the next atom really fast. The more atoms we have, the safer. Because of friction, I suppose, you might call it, I use a word like that, because there's more atoms that have to keep passing through, slow light down.
Yes. Okay, so the question is, can light slow down traveling through matter? And the answer is yes. Different materials in the laboratory, you can slow light substantially. I might have heard an article recently that said they were able to essentially stop it. I mentioned something similar before when I mentioned that sunlight takes a long time to travel from the inside of the sun where it's produced out to the surface. It's for that exact reason. It's emitted, or produced, I should say, by fusion, and then immediately absorbed by solid matter, which then emits it, and then it's reabsorbed, and emitted, reabsorbed, and that process takes a long time for the light to actually make it out to the surface. So yes, it's a real effect. How you would apply that to the light travel issue, I don't really see a way to do that, especially because if anything, you'd have the opposite problem. If the Lord stretched out the heavens and everything used to be more compact in the beginning, so if anything, light would travel more slowly in the beginning if that were a significant effect across the cosmos. So good idea, but I don't think that would be applicable to this particular question. Yes?
Question. So all these pictures from NASA, are they actual authentic photographs or CGI is involved in some of stuff?
Where you saw something moving, that was typically an animation.
Yeah.
Most of these things, like this is a photograph. Most of these things are photographs.
Picture of the satellite or something like that.
I'm sorry?
Picture of the satellite? Is that all?
Picture of the satellite. That's a graphic.
Yeah.
Yeah.
Why are they always using computer CGI when they're giving us pictures of things?
They're not always. You can get photographs. I couldn't get a good photograph of GPS. In order to take a photograph, you need to have a camera that can get a good picture. So most of the photographs are in things of near Earth orbit. Like there's plenty of photographs of the space station or taken from the space station, International Space Station. But satellites that are farther out, you're not going to be able to get a photo of them because
The big ones of the Jupiter and whatever the planets, are those CGI? All colored and nice and...
there are a lot of good photographs available. They've been processed a bit usually because, back up a minute. You can take pictures of Jupiter from Earth, and you can see it in your backyard telescope, but they're not going to be very big, and so they're not going to have much detail. We have sent multiple spacecraft into the solar system that have taken photos. The quality of the equipment has increased over the years, so Voyager, back in the 70s era, the stuff we have today is much better. A lot of times those pictures require a bit of processing because these are CCD cameras and radiation from space will cause pixels in the CCD to fire and contaminate your photo. So you generally have to take a bunch of photos and then overlay them to remove all the contamination, so to speak. There's no one good picture taken where someone took a film camera and took one good photo. So there is some processing, but there are many photos available. Yes, ma'am.
Is there any research going on right now where you're kind of waiting with bated breath to see what's going to come of it to help inform which of these theories?
For this specifically or creation in general?
Well, I'll say in general.
Oh, boy, where do we start?
Okay.
There's lots of good work being done on dinosaur soft tissue. Are you familiar with that? Well, other people might not be. So I get to take all sorts of fun tangents tonight. A number of years ago, it was discovered that a lot of dinosaur fossils have soft tissue within them. I'm sure some of you are familiar with this already. That was a surprise to many people, and so wasn't explored in depth. Now we have the opportunity to do that. So the initial discoveries were soft, almost beef jerky-like flesh from within a tyrannosaur leg bone, clearly not millions of years old, along with blood vessels and blood cells, dinosaur blood, in the laboratory. It's pretty cool. Now that people are aware that such exists, more people are looking for it and are finding it because it's always been there. Just no one looked for it before because it's millions of years old. Why would you look? But now there's evidence of blood coagulated in some bone samples I'm aware of, and actually Julie could tell you more about that, including things like, which I hadn't seen before, that photo of worms consuming the coagulated blood inside of the fossil. Have they been eating for 65 million years? No. So a lot of good work being done on that. In the physics area, some of these models here are being developed as we speak. There's some other ideas being proposed, some of which I didn't even have time to talk about tonight. So this is a very active area of research. There's a lot of good work being done in genetics. It's been known for a few years now that we're all descended from one man and one woman. You can show that with genetics. But there's more insights even than that that are being gleaned. More insights into the accumulation of harmful mutations over time in a population. So Darwinian evolution requires us to be getting better and better, but we're actually getting worse and worse. And there's a better understanding of how that process happens. So lots of good stuff going on.
Thank you.
Yes?
So, in your presentation, you gave pretty clear implications that there were 3 questions you wanted asked.
Right.
I only remember one of them, so I'm going to ask the one that I remember and then ask you to recall to our minds what are the other 2. And the one I remember is you implied that you were partial to one of the views,
Mm.
but you weren't going to disclose it unless somebody asked you. So I'm going to ask that question and then ask you to elucidate what were the other 2 and answer.
Oh. I don't think I said I would reveal if asked. I said I expected people to ask, but I wouldn't necessarily reveal. I think we need multiple elements from several of these ideas. We need mature creation extending out at least to the sun, for sure. Several of the other proposals that I mentioned have aspects of mature creation within them that perhaps some of the discussion isn't addressing. So I don't think we're quite there yet in a cohesive proposal, which is why I'm presenting this the way it is. My goal is to show we have a lot of tools in the toolbox to use, and that this issue is not this showstopper for us as it's presented to be. I'm not sure that any of the individual proposals have worked out all the bugs yet, so to speak. I think my personal expectation is that the ultimate solution is going to require elements from several. So, and the other 2 were that every secular model of origins for the universe has to violate the laws of physics unless there's a creator involved. And the third was a demonstration that you can't have an absolute sequence of events on cosmic scales. So any interest in either of those 2?
Yes.
Okay. So
Start with the demonstration.
start with a demonstration. Okay. For the demonstration, I need 2 brave volunteers, whom I promise not to embarrass too badly. Okay, one hand. Yes, sir. If you come down to the front, please. Yeah, there was a qualifier at the end of the statement. Okay. Going to be hard to do this and hold the microphone. If you could stand over here, and gentleman number 2 will stand to my right. Thank you for joining me.
Thanks for having me.
Okay, so we're going to do an experiment. We're going to try to clap our hands simultaneously. So I'm going to clap 3, 2, 1, and when I would have reached 0, I'm not going to say 0, we're all going to clap our hands together, and then they're all going to judge us as to how well we did. All right? Okay. We won't even do a warm-up. We'll do it from scratch. Ready? So 3, 2, 1, clap. Oh, okay. Now we're getting thumbs down. Harsh critics. Okay, let's assume that we were able to succeed. You would have heard basically one big clap. And we all would have agreed that we heard one big clap, right? That's because we're all in the same room next to each other. Now, let's mentally do a different experiment. You are going to move 1 light year in that direction, and you're going to move 1 light year in that direction, and we'll do the same experiment. Now, we're communicating over cosmic Zoom call, and radio waves travel at the speed of light, which means it takes how long for my signal to reach you? Over 1 light year. 1 year, right? Okay, and similar over here. So we're not actually seeing each other, we're only using monitors and such. Now I do the same thing. I say, okay, let's all together clap after 3, and I count 3, 2, 1, I clap my hands, and then I wait. And that signal takes a year to reach you, right? And this is a live demo, so we're going to go home and we'll see you back here. No. Okay. setting that aside, a year later, you finally see the image of me saying, okay, let's clap together, 3, 2, 1, and you clap with me, and then the signal goes back to me. Meanwhile, the same thing is happening this way. So, in the first demonstration, we all clapped together, right? So who clapped first in the first demonstration? Nobody. We were simultaneously, well, assuming we had done it right. Assuming we had actually got it, all three of us would have clapped at the same time, right? Now, merely by introducing distance, what happens? From my perspective, I clap first alone, and then I wait 2 years, because the signal takes 1 year to go out and 1 year to come back, and then I see both of them clapping simultaneously. Sorry about the microphone. From your perspective, what do you perceive? You and I clap together. 2 years later, he claps alone, right? And same thing for you. You perceive us clapping together, and 2 years later, he claps alone. Which of the three of us is correct? We all are, because there's no absolute sequence of events when the scales of distance, and also even motion, which we haven't even introduced here, are introduced. So applying that to cosmology then, the idea that God can create galaxies way out there and then progressively farther and farther inward so that all the light arrives here on day 4, people say, no, that means God created that stuff billions of years before the earth. That's not what Genesis says. Well, no, you can't use the word before, because before means there's a sequence, right? And the sequence depends on which observer's perspective you're going from. From the Earth's perspective in that cosmology, the Earth was created first, and then suddenly everything else appeared. Now, from a galaxy's perspective, not to reverse anthropomorphize here, but from a galaxy's perspective, the galaxy was created first, and the Earth hasn't been created yet, because there hasn't been enough time for light to get here from Earth to out there. But that doesn't matter, because Genesis is written from the Earth's perspective. Thank you, brave volunteers. So does that make sense, that there's no absolute sequence through which to interpret things? It all depends on the observer's perspective. Yes, sir?
I'd just like to offer one support for that, is that in Genesis 1, when it talks about making the stars, it doesn't say he made them on that day. It says he made the sun, the greater light, the lesser light, and then it says he made the stars also. It's a separate sentence, separated from the other thing.
In English translations, yes. In Hebrew, no. There's a part.
Seems to imply that they were made.
Yeah, there's a particle in Hebrew that you use to denote a direct object, something receiving the action. It's called et. There's no direct equivalent in English. But the Hebrew there says, God made the greater light to rule the day, and et, the lesser light to rule the night, the moon, and et, the stars. So it's actually just two words, ve'et ha-kocharim, and also the stars. But it's tied into the previous thought. So there's no separate verb there. Yes, sir?
It would seem to imply if he created the outer stars first, that he built everything for us to see. Can't work two places in the universe.
Right, yes. And it would imply that the Earth is at the center of the universe.
That means everything was done for us, if that's true.
Correct. And, I mean, that's a biblical idea. The Bible doesn't demand that, but it's consistent with it. Yes, sir?
Along that same line, as you just mentioned, I know that the secular scientists don't want the Earth to be the center of the universe. What evidence, other than the redshifting discovery, is there that you might really be the center?
Yes, the question was, and I apologize to people who watching online that I'm not repeating questions for, unfortunately. Sorry. Is there evidence for us being at the center? When we look out at distant objects, and by distant I mean like beyond our local group of galaxies and such. So I mentioned, like, for example, the Andromeda galaxy is moving toward us. But as you look farther and farther out, cosmic expansion becomes the dominant effect. So except for the stuff close by us, as we look farther and farther out, light from these objects is more and more redshifted, which is how we know they're more and more distant, getting back to the question earlier. That means, okay, so we look this way and everything is redshifted. Everything appears to be moving away from us. The same is true if we look that way and that way and that way. In all directions, stuff is moving away from us. So there's two possible interpretations. Number one, we appear to be at the center of an expanding universe, but that's an illusion because it would look that way from anywhere in the universe. Or option B, we appear to be at the center of an expanding universe because we are at the center of an expanding universe. Which do you pick? There's no data demanding either one. The data are consistent with both interpretations. A Big Bang modeler picks option number one. And a fundamental assumption of the Big Bang is that the universe has no center. Therefore, if we appear to be at one, it's an illusion because there isn't actually one to be at. So the Big Bang model contains, this is called the Copernican principle or the cosmological principle. It's an implicit assumption built into the very beginning of the Big Bang model that the universe has no edge and no center. But that's just an assumption. We're just as free to make the other assumption. Or I should say interpretation. That we appear to be the center of the universe because we are. The redshifts are consistent with that. So that doesn't prove that it is because you can interpret it the other way, but it is consistent with that. Oops. I saw a hand. Let me go back here. Yes?
And if God lives outside of time, he sees the future and the past at the same time,
Uh-huh.
then we really can't say he created the stars first.
If God is outside of time, we can't say he created the stars first.
All at the same time.
Well, from his perspective, that would be true, but from our perspective, we have to figure it out. So once the Lord started creating something, then there was a physical universe, and then time would apply. Not to him, certainly, but to us. So once we start discussing objects, then the order of creation might become an issue, depending on your perspective. Yes, sir?
I thought that Halton arc disproved that redshift was a distance measuring device.
Halton Arp, I don't think he was questioning cosmological redshifts absolutely. He was focusing on specific examples. Quasars especially were something that was focused on by that, and certain galaxies. So I think his work is very interesting. For those of you who don't know, Halton Arp was an astronomer who passed away a while back, who was digging into some really interesting anomalies in galaxies and their correspondence between redshift and distance. The larger community didn't care for the direction that he was taking his research, and so he wound up being denied telescope time and unable to continue. And it wasn't censorship, it's just that, well, telescope time is limited, it's a valuable resource, and we don't think that's a really productive way to be spending it. So he wasn't a creationist, but an example of, I want to say censorship, but that maybe scientific research isn't as open to new ideas as is commonly claimed. So to answer your question, I don't think his work discredits all redshifts. Quasars specifically, there's been a lot of interest in that, and maybe some other specific examples. So that's my answer to that. Yes? The relation between motion and time. Motion slows time down for the mover. So GPS satellites, I mentioned, they experience relative, let me rephrase this. With GPS, they experience time more quickly than us, by 45 microseconds a day, but because they're moving relative to the Earth, they lose 7 microseconds per day for a net of 35, if I remember the numbers correctly. That's another possible tool for making a cosmology that no one has really tried yet. More challenging because you'd have to have the Earth moving relative to the distant stars. But something else maybe someone should look into. Yes?
The time dilation thing seems demonstrable in satellites and that kind of thing, but the big model where the universe is created smaller than the event horizon and goes out beyond it, is that a secular origin of that idea, or is it a creationist thing? Who's working on it?
The time dilation cosmology came out of the creation community. That's Dr. Russell Humphreys, a retired physicist. So yeah, that idea was his. And he's subsequently developed it more fully since then. His earlier version, which I presented here, didn't include things like the effects of the waters above. He presented just all the matter in a ball, and that got stretched. Now he's introducing a separation of the waters below from the waters above. If there's a thin shell of water on the exterior edge of the universe during that process, what would that do? But it makes everything significantly more complicated. And I just want to show people that time dilation, A, is real, and B, can be applied toward this question, which is why I talk about the first version. Anybody want to talk about the secular cosmologist violating physics necessarily? Okay. I call this the secular dilemma. And it's based on a simple question. Did the universe have a beginning? Only 6 words. Not a complicated question, right? If you think about it, when you build a cosmology, you have to answer this question in order to choose what category of model you're going to wind up with. How many possible answers are there to this question? 2. Everyone's not so sure. I said, well, the last guys that raised their hand got dragged to the front and made to clap. Yes, there's only 2 answers. Yes, there was a beginning, or no, there was not a beginning. And if there wasn't a beginning, the universe would therefore be eternal. And I call this a dilemma because a dilemma is a choice between equally unfavorable alternatives. You have to pick one, but you don't want to pick any because they're all bad. And it turns out that for the secular scientist, the answer to this question, either yes or no, are both bad because they each violate physics in a different way. So let's talk about that. If you answer yes, the universe had a beginning, well, if there was a beginning, then what began? If the universe is everything, which is what the word means, then everything had a beginning. Well, if everything had a beginning, then what was there before the beginning? Nothing, right? Because if there was something before the universe began, then whatever began wasn't actually the universe because it wasn't everything, right? It was only part of everything. Too much word salad? Well, point is, if you say the universe had a beginning, then before everything began, there could have been only nothing. So here's a graphic of what the universe would have looked like before the universe began. That's, of course, it's only an artist's conception. So to answer the question from earlier, this is not a photo. So can you go from nothing to everything, though? Can nothing make everything? Can nothing make anything? Well, no, because nothing can create nothing. Nothing can do nothing. From nothing comes nothing. Dr. R.C. Sproul once said, if there was ever once truly nothing, there could never be anything, which is kind of profound if you think about it. And Dr. Phil Fernandez said, you can't tell me nothing made something. I know too much about nothing. So this seems like common sense. Nothing can create nothing. You can't get anything from nothing. Well, this is actually not merely philosophy. There's actually a law of physics that reflects this. Sometimes called the first law of thermodynamics, more accurately called the conservation of mass energy, that the total amount of matter and energy in the universe is conserved. It never changes. The total combined amount of the two never changes. Now, you can go back and forth between the two, but you can't change the total amount. What do I mean by go back and forth? Well, physicists have understood for a while now that matter and energy are different forms of essentially the same thing. You may be familiar with the equation E equals mc squared. It tells us energy equals mass, the amount of stuff you have, times the speed of light squared, and the speed of light's a very big number. So that tells you that a little bit of stuff is equivalent to a lot of energy. And we can convert them back and forth. So how do we convert a little bit of stuff to a lot of energy? Well, the most efficient way we know how to do that is a nuclear explosion. Small amount of matter converts into large amount of energy, but you're not getting the energy from nothing, right? You had to start out with the bomb to get the explosion. You can go the other direction too and turn a lot of energy into a little bit of stuff. And we do that in particle accelerators. You get little chunks of matter zipping around close to the speed of light, smash them together. More stuff comes out of the collision than went in. Now, I don't just mean the number of particles, I mean the amount of matter. But we're not creating the matter from nothing, because that violates this law of physics. We're converting the kinetic energy, the energy of motion, into matter. So my point is we can convert matter to energy, we convert energy to matter, but we can't create either from nothing because that violates this law of physics. And we see this principle in our lives every day. I mean, if you think about it, why do you need to eat food every day? Regardless of how difficult the process might sometimes be. Because your body needs energy to work. Can't get it from nothing because that violates physics. You need to get it from the chemical energy contained within the food. Because you have to get it within your mouth first, but that's a problem outside of physics. Why do we get a bill from the power company every month? Because your appliances need energy to operate. Can't get it from nothing because that violates physics. Need to get it from the power company, which also can't get it from nothing because that violates physics. It has to get it from the chemical energy stored in coal or the gravitational potential energy in flowing water. or solar energy from the sun, which also can't get it from nothing because that violates physics. It has to burn hydrogen and so on. Point is, we see this everywhere in the world around us. In fact, you couldn't be watching this presentation tonight if it weren't for this law of physics, because some of the principles of circuit design are based upon it. And of course, we're using electronic devices to have this presentation. As one of my textbooks points out, conservation laws are the guiding principles of physics. These are absolute conservation laws. They are always obeyed. So this is a formal expression of the fact that something can't come from nothing. Now, if you're interested in science, and especially cosmology, you might be familiar with the fact that there are people who claim it can, that the universe did come from nothing, like this book proposes. Now, if you saw the title, A Universe from Nothing, what would you expect the book to explain? How the universe came from nothing. One of the first things that he says in the book is that what he means by nothing is not really our definition of nothing. He means the universe came from an empty vacuum of space-time that was permeated with quantum fields that fluctuated. Well, then where do the quantum fields in the empty vacuum of space-time come from? That's left unaddressed.
Sounds like a miracle.
Sounds like a miracle, yeah. Point is, back to our dilemma, did the universe have a beginning? If you answer yes, then something had to come from nothing, and physics doesn't allow that. Well, what about the second option? No. Well, if there wasn't a beginning, then the universe has always been here, so it must be eternal. Does physics allow that? No, it doesn't. Here's an illustration. If you walk into a room and there's a hot cup of coffee on the table, has it been there a long time or a short time? Short time, because had it been there a long time, it would have cooled off already. Can it have been there forever? No, because had it been there forever, it would have cooled off forever ago. So you can use coffee as a crude form of clock, right? We can use the same logic and apply it to the universe. Is there anything in the universe that hasn't cooled off yet? Lots of things, right? If the universe had been here forever, stars would have cooled off forever ago, and they wouldn't be here anymore. But of course, they are still there. Now, some people will object and say, wait a minute, new stars can form. There's actually issues with that. But setting the issues aside, star formation still requires energy. There's only a finite amount of that available in the universe. That would have been consumed forever ago as well, had the universe been here forever. So the fact that heat energy is still unevenly distributed, in other words, stuff hasn't cooled off yet, tells us that the universe is not eternally old. And as an aside, by the way, sometimes Christians say we should embrace the Big Bang model because it says that the universe had a beginning and that's consistent with Genesis. The Big Bang model actually is not consistent with Genesis, but setting that aside, the point is we don't need the Big Bang model to show that the universe had a beginning. If you want to prove the universe had a beginning, just go outside and look up. Do you see the sun by day? Do you see the stars at night? If so, the universe is not eternal, therefore it must have had a beginning. Now, within the secular community, there are people who wouldn't like that claim. They would say, well, wait a minute, yes, the Big Bang was a beginning, but not actually the ultimate beginning, because there's always been something. We're in this eternal cycle of Big Bang, the universe expands, slows down, and then contracts and collapses, and then a big crunch, and it rebounds, so bang, crunch, bang, crunch, bang, crunch. This is called the oscillating universe model. And they will tell you that that's been going on forever. Physics doesn't allow that either, for similar reasons that you don't have if I drop a basketball, it's not going to bounce forever, right? It'll bounce a few times and then stop. You can't have this eternal cycle of bang, crunch, bang, crunch. That's essentially a perpetual motion machine, which physics does not allow. So moving on back to our dilemma, we saw that yes means something had to come from nothing, which is not allowed. Now we see that no requires the universe to be eternal, which is also not allowed for different reasons. And if you're a secular model builder, these are your only two options. And physics disallows both. Now, as Christians, we have a third option. There's a supernatural creator outside of the universe that is responsible for it. And this is the only explanation that doesn't violate physics, right? There's a creator outside of physics who brought the universe into being. Because if you think about it, the fact that the universe exists should be explained. There's only three possible ways to do so. Either it was formed by a creator, or it formed without a creator, or it never formed at all because it's always existed. We saw that option 2 means something had to come from nothing. That's not a viable option. Option 3 means the universe would have reached equal heat distribution by now. Every star would have died. The entire universe would be the same temperature. That's not what we see. So the only option left is that it was formed by a creator. And I mentioned in my earlier presentation, we shouldn't be ashamed of believing in a miracle for the origin of the universe because everyone does. Without a creator, your model has to violate physics one way or the other. That's kind of the definition of a miracle. So we believe in a miracle because we know who did the miracles. The other side believes in miracles while denying that miracles are valid. And this is also, by the way, not just a theoretical dilemma, it's also a great conversation starter. Right? It's a simple question. Did the universe have a beginning? Two possible answers, and you can show people, well, if you say that, then it means this. If you say that, it means that. What are you going to do? I also argue, by the way, the Bible doesn't say this specifically, but I think this is evidence of God's grace. The Lord could have made the universe in any way he wanted. He could have made a universe that looked like it was the outcome of natural processes operating over billions of years, while simultaneously telling us in his word, that's not actually what happened. I did this in this way. Trust me. Now, had he done that, how many of us would struggle to accept what the Bible says, right? But that's not what he did. The Lord made the universe in such a way that the laws that it operates according to, weird grammar there, but the laws according to which it operates also show us that he must be responsible for it being here. He doesn't ask us to trust him in violation of our minds. He asks us to worship him with our heart, soul, and minds. In his grace, the Lord has put us in a universe that looks created. And I just love that. So that is the end of my time tonight, unless there is maybe one last question that someone just has to ask. No? Thank you for the questions you did ask and your participation. What is the furthest that we can see? Currently, 13.5 billion light years. And that boundary is being pushed back farther and farther.
Is that what the new telescope,
The new telescope, the new James Webb telescope, that is fun. We could do a whole presentation just on that one. Okay. Going late is now your fault. So,
I just wanted to say thanks for giving God a toolbox to work with.
oh, no, he made his own toolbox. We're just here trying to figure out the details. So brief word on James Webb, and then we'll close. So James Webb went up recently, is able to look out farther into the universe than Hubble could, and is also able to look into the infrared better than Hubble could. And this is fun because already back in the Hubble era, before James Webb was even up, we were able to look far enough into the cosmos that from a Big Bang perspective, we'd be looking back in time. Like the whole point of my presentation tonight is that distant objects don't necessarily need a long time for the light to get here, but the Big Bang model would say that it does. So in a Big Bang perspective, the farther out we look, we're looking back into time, essentially. So if we see an object 13.5 billion light years, we're looking light years away, we're looking back 13 billion years into time. Big Bang model predictions were galaxies would need several billion years to form. So when we could, and the universe is supposed to be roughly 14 billion years old. So therefore, after we started looking past 12 billion light years or so, we're now looking into the period when galaxies were supposed to be forming, according to the Big Bang. Still with me? Hubble was looking out to those distances and beyond those distances and finding mature galaxies as far as it could see, which is a problem for the secular perspective. So they had to try to go change their models and all the rest of it. They did take some comfort in the fact that in the farthest regions that Hubble could observe, galaxies looked a bit different than they do, or than the closer ones do. So they said, okay, so apparently galaxies can form more quickly than we thought, but at least there's some evidence of their evolution visible on the outer edges of what Hubble can see. Then the James Webb went up. James Webb has been re-observing some of those same regions Hubble did and finding that the places where we thought galaxies, I shouldn't say we, the places where it was thought that galaxies were seen to be evolving because they look different, turns out there was a lot of dimmer galaxies that Hubble wasn't able to perceive, but James Webb can, that are still fully mature. So it took away the explanation for the regions Hubble was able to see, and in the regions even farther where Hubble couldn't see, James Webb is observing mature galaxies all the way out. So my personal speculation has been for a while that they're going to have to increase the time, or the age of the universe, basically, because the Big Bang believers are running out of time in which to make anything. They're looking almost back to when the universe itself supposedly began, and there's mature stuff all the way back. So makes sense from our perspective, but they have a problem. So I'm expecting them to change the age of the universe again. It's happened before, so why not do it one more time? Thank you very much for your attention. Been a great group tonight. It's been a privilege.